Any questions? Brittany, I think I saw your
Yeah.
nod.
I have no idea how to do number 6. On the master set. Sorry.
That seems like that was not the original one. So you've got a box sliding along the floor. And then there's up the hill. All right, so it turns out that the mass actually is irrelevant to it. The initial speed is not. That is relevant. So we're dealing with something like that. And I've got a box floating along, moving along, not floating. At some speed here, if I'm going to give a mass anyway, 31 kilograms, traveling at 15 meters per second. Obviously, these are not the same numbers as are in the problem. And at the end, I said how far above the level surface. So basically, how far that way, I believe, as opposed, for some, there have been some problems where I've wanted to know that distance right there, and people, just, so to specify or make it clear, I want that distance. Obviously, I will hope, hopefully, wow, English not coming to me today. I'm hoping that when you saw this problem, you were thinking energy. Since this is chapter 7, right? Yeah. So, the only way that energy is not conserved if there's a non-conservative force doing any work. So let's think about it. When it's on the hill there, what are the forces acting on it?
Weight and normal force.
All right. Are either of those non-conservative? That is correct. All right. But the normal force is not doing any work. Why not?
Because it's perpendicular to the surface. It's not in the direction of movement.
Yes. So therefore, since this is not doing any work, we're left with weight, which is a conservative force, so energy is conserved. So that's just the background, the rationale for why we're going to use conservation of energy. So the initial energy is equal to the final energy. Well, I'm assuming this thing is not combusting into flames. It's not somehow exploding, so we're not worrying about any change in rest mass. All we're worrying about right now are the other two types of energy. And what are they?
Potential.
And
Rest.
Kinetic.
that's the other one I want. So we have some kinetic initial plus some potential initial is equal to some kinetic final plus potential final. All right, I'm going to walk over there and close the door just a little bit, but while I'm doing that, you should be thinking about the answer to the next question I'm about to ask, because you're going to sing in the chorus of angels the answer. So what's the formula for kinetic energy? I do appreciate the people who spoke, but it was not particularly in unison. Oh, one more time, just Jessica's. What's the formula for kinetic energy?
1/2 mv squared.
All right, we'll work on enthusiasm next, but thank you. So 1/2 mv initial squared plus something. And over here, 1/2 mv final squared. All right, what's the formula for potential energy?
Which one?
Thank you. The one associated with weight.
MGH
There you go. Every term has mass in it, so we could cancel mass out if we want to, make life a little bit simpler, or we could just go ahead and throw the 31 in there, or the, I think, 50 in the problem. It depends upon how much math you want to do, how much when you use a calculator. Personally, I would get rid of mass. So since every terms are added and subtracted, factors are multiplied or divided. So we're adding here, so these are terms. If I have the same thing in every term, all in the numerator or all in the denominator, I can get rid of it. And we've simplified it. So now, well, what do we know? Let's see. We know initial speed, 15 meters per second here, and I think 20 in the problem. We know G. We know final speed. What is the final speed?
0.
Yes, why?
Because it stops. Because it stops.
Presumably, if you want to know how high up it goes, it has to stop in order to identify, hey, that's how far up it's going to go. We're left with this H though. The trick with H is we have to figure out where 0 is. Or not really figure out. We get to decide. Where is H equal to 0?
Do you just want a random number?
Pardon?
Do you just want a random number?
Location. Just tell me where 0 is.
20 meters? I don't know. When it gets to the top of the hill.
When H is 0 here?
Yes.
Okay. I would have gone from down there, but that's fine with this. So wherever, so top of the hill, you're talking about the top of where the hill is, or as far up as it will go?
Right there, as far as it'll go.
Okay. All right. So what she has done is establish this is 0, because Hannah said so.
I like that reason.
And now we plug and chug. So I have 1/2 times my initial speed of 15 squared plus 9.8 times my initial height equals, well, I know that's 0 because it stops, and that's 0 because Hannah said so. There's our math problem. We plug into a calculator. 15 squared is 225 times 1/2. 112.5 plus 9.8 H is equal to 0. And then solve for H. I'm trying to get H by itself. Please do not add these together first. If they could be added together, I would have done that already. We need to first figure out what 9.8 H is and then solve for H. So we have to get this over to the other side. So we get 9.8 H is equal to negative 112.5. Now we can get rid of the 9.8. 11.7 negative. I don't know what it actually is, but
How many decimal places?
that's fine. 1 decimal place is probably sufficient.
11.4.
11.4,
Give it 5. Give it 5.
11.5 units.
Meters?
Is it
Like you need it.
Meters.
Yes. Yes, Kimberly.
How do you get 9.8?
I'm assuming that the problem takes place on Earth, and this value of g here, that's the acceleration due to gravity.
Oh.
Yep.
So if you're gonna put zero, like, I don't, well, could you put it at like the base of the hill?
Absolutely.
Said it would be positive because, it's only negative because of
Yes.
okay.
Yeah. Now, when we're dealing with vectors, we decide which way is going to be positive or negative, but when you're dealing with this, h gets bigger as you go up, it gets smaller as you go down. So the fact that it's negative is expected. If I'd gotten a positive number here, that, since positive height would have been above it, so negative h below it, which makes sense, because that's where we started. So this is h is equal to negative 11.5 meters. This is 0 meters. So the answer to the question of how far up the hill or how far up it goes, it would be 11.5 meters.
So it wouldn't be negative?
Negative is just the initial height, and it ends at 0. So to actually answer the question, you need the positive. Other questions? I'm about to solve it if we chosen h to be 0 at the bottom, just to show how similar it is. Any questions before I do that? All right, so if we chosen h is to be 0 at the bottom, so everything's the same until we get to this step. What's in blue here is the same. We can get rid of the mass, that still holds. Then we come down to here. We would have 1/2 times the speed squared plus 0, because now we're saying 0 is at the bottom. So my initial height is 0, because I say so. Then we come here, that's still 0. The final speed is still 0. What is different is the final height. And so this is 112.5 is equal to 9.8 times h. Which looks like it's about 11.5, I would say. So we get, in the end, we get the exact same answer. There's 11.5 meter difference between where it stops at the top and where it starts at the bottom. Now typically, if you're not quite sure where to make h is equal to 0, my recommendation is pick a place where one of these terms is going to be equal to 0, just to get rid of one of them. Other questions on this one? Other questions?
What's the number for the speed of light again?
How exact do you want it?
Whatever you want us to use in the equation.
Where do I? Typically, the speed of light, 3 times 10 to the 8th meters per second. That's a good enough approximation. It's 2.99, at that point I forget. And there is an exact number, and whenever I need it, I usually go to Google and just say speed of light, and it comes up.
Can you show the one with the spring?
One with the spring. All right, so it slides along a flat frictionless surface until it reaches a spring. If the spring constant, maximum spring will compress, you must show your work. All right. Well, why don't we stick with the same thing here? And K will be 30 in that, 30 newtons per meter? I'll make it 20 newtons per meter. Now, this is a situation where the mass does matter. Before the mass canceled out, if we had put 31 into those other problems, into the previous problem, we still would have had the same answer. Now, however, we can't cancel the mass out. That's just, the back end is not going to fall. It's not going to hit the spring is going to go flying. The spring is just going to compress. So what are the forces acting on the mass when it hits the spring?
Normal force.
There's another force,
From what?
from the 15 meters per second going towards the spring.
No, not from that.
Spring force.
Yes, there's a force coming from the spring. The spring's pushing against it, and the more the spring is compressed, the more it pushes. So there is going to be a force this way, F sub S. Since it's moving to the right and the net force is to the left, it will slow down, which makes sense that as it compresses, I would expect the mass to slow down, not speed up. All right, so of these three forces, which ones or one will be doing any work? Yes, that will be. Positive work or negative work?
Negative.
Absolutely. What about the other two?
They're not doing any work on it
Why not?
because the way the forces are acting on it.
More specifically, I think somebody said it over here.
Equilibrium.
Oh, no, I heard a different.
Cancel each other out.
No, well, actually, if they were doing any work, they would cancel each other out in this particular case. However, if one of them disappeared, well, how many laws of physics do I want to break right now? There's another reason besides the fact that they would cancel each other out why they're not doing any work.
Because of the forces are not perpendicular to, no,
Nope. Because they are perpendicular.
they are perpendicular. So
They're perpendicular to what?
The spring.
The,
The spring.
not the main reason why there's not work being done.
The ground.
Indirectly.
I think what I'm trying to say is, since the object is coming this way and not this way, normal force and weight wouldn't be a factor.
Right, and just summing that up, those two forces are perpendicular to the movement. The movement is horizontal, so any vertical forces for horizontal movement do no work at all. All right, so. I'm about to ask that question again. Everyone get ready. Psych yourselves up. Tears of joy, that's what you're aiming for. Tears of joy. What's the formula for kinetic energy?
1/2 mv squared.
No tears of joy, but I do appreciate the better than the last first time. All right, so I got 1/2 mv squared initial. All right, what's the formula for potential energy?
Which one?
Which one?
Thank you. The one associated with the spring. With the spring force.
1/2 K, times the distance squared,
Displacement.
displacement.
Oh. Yeah, sorry, there was no vector symbol over it, so yes, I apologize. 1/2 K delta X squared, initial, plus 1/2 K delta X squared. All right, so at this point, let's try to figure out what we can get rid of. We have 4 terms here. Which of these terms are 0 and y? Which one? I got 2 of them. Which one? Sorry? No, not both of them. So why is the first one 0?
Because that's where it started.
Okay.
So we can just assume it's 0, I guess.
Oh. It depends on what you mean by assume. Are you doing it like with where h is equal to 0, that type of thing? Yeah, not that reason. We cannot, with the spring, we can't just go, oh, let's just make this place 0.
Would it be the final?
Why?
Because it's gonna spring back to where it started from.
All right, so let's talk a little bit about what this is.
Okay.
That's the quick answer. A spring has a natural length. And so what this is a measure of how far you are off of that natural length. If you stretch it or whether you push it, whatever that natural length is, that's basically 0. So before anything hits it, the spring is just sitting there. Excuse me. The spring is just sitting there. And so because it is just sitting there, presumably in its natural length, that's why this is 0. And so when it's most compressed, it definitely cannot be 0 because it's definitely not the spring is not in equilibrium, which I guess goes to Hannah's point. It does want to move back to here. It is not in equilibrium. All right, so as a hint, there's one other thing that we can set equal to 0.